We are the only android life in the known universe. I mean, imagine that we are the key place where there is information in this boundless framework. Cosmologists throughout the world are in awe of this continuously advancing discovery. The James Webb Space Telescope has captured the elusive focus of city lights, an unfathomable 7 trillion miles from Earth. Beating all odds, this amazing achievement does more than just extend our perspectives in terms of what we know about the universe. The theory goes wild as scientists pore over the data, searching for signs that could unlock the secrets of these puzzling, incredible objects. The possibilities are astounding. Check that we are following in the footsteps of a few extraordinary individuals in the universe, and that the universe is overflowing with life and development, extremely far beyond our capacity to grasp. Could it be that these far-off lights indicate the presence of extraterrestrial civilizations? What does this mean for our understanding of the possibility of life beyond Earth? Join us as we take a look at how the James Webb Telescope recently observed city lights 7 trillion miles away. Launched into space on Christmas Day 2021, the James Webb Space Telescope, JWST, was designed to surpass the highly respected Hubble telescope in capturing extraordinarily sharp images of newfound brilliant objects, planetary systems, and more. A clear objective of the JWST is to focus on the movement of the earliest universes by looking at the faraway neighboring inhabitants of the universe. This is feasible because the journey time of light across our universe is billions of years. When the JWST gathers light, it captures these objects exactly as they were billions of years ago. Space specialists measure distances in light years, which is the distance light can travel in 1 year. To illustrate this, the mission's first major practical endeavor was a massive field image that was presented on July 11, 2022, by U.S. President Joseph Biden during a speech from the White House. While the Hubble Space Telescope focused on a solitary region of the sky for 10 straight days starting on December 18, 1995, the Hubble Deep Field gained fame. The region was only a small spot, making up about 1/1,000,000th of the entire sky. The majority of the 3,000 currently invisible objects discovered by Hubble were enormous galaxies found billions of light years away. With its focus on the SMX 0723 galaxy group, the JWST's deep field covers a similarly small area of the sky. The galaxy design SMX 0723 is 4.6 billion light years away, and the more distant galaxies behind it are amplified by the intense gravitational field. The light from a distant galaxy was confirmed to have taken 13.1 billion years to reach the telescope after traveling through space. The light produced stretches as the universe grows. The primary goal of the JWST has been to capture visible light from their stars into the infrared. Stargazers can clearly identify JWST and visible light photos of nearby galaxies taken by Hubble and other telescopes. By collecting data at those frequencies, we can see how galaxies have evolved over immense timescales and merged into the shapes we observe today. More remarkable than the sheer number of structures in the JWST's first deep field image is how quickly it was captured, in only hours, compared to the days or even weeks required by other telescopes. Wherever it looks, the JWST uncovers more galaxies. Universe groups aren't the only objects acting as amplifying centers. Specialists used the JWST to capture an image of several galaxies designated VV1191, so they could study how the light from one of the pair changed as it passed through the other. The results of this study will reveal the properties of the intervening galaxy's evolution. Additionally, it seems that the JWST may have made an exceptional discovery: light from an extremely distant galaxy. The announcement of the possible presence of auroras on an exoplanet came from the official JWST site. The absence of a host star and the cold temperature makes it difficult to pinpoint where the energy in the upper atmosphere is coming from. However, the fact that the object showing auroras is indeed producing methane is crucial. Just like auroras on Earth are caused when energetic particles from the sun enter space and are captured by Earth's magnetic field, charged particles then make their way through Earth's atmosphere near the poles, creating the spectacular light show known as the aurora borealis. Jupiter and Saturn have similar auroral phenomena because of the solar wind. However, the strange W1935 has no star to orbit, so its auroras are a significant mystery. Everyone's attention continues to focus on Proxima Centauri TRAPPIST-1, around 4.4 light-years from Earth, within the Milky Way galaxy. Specialists have identified the presence of water on the exoplanet, and the possibility of life on the planet cannot be ruled out. Are we finally going to see evidence of life beyond Earth? Just last month, the JWST noticed another extraordinarily large black hole. This colossal black hole was seen in different frequencies and is consuming everything around it. This discovery is 40 million times as wide as the Sun. But what's the significance for us? The JWST has found that this gigantic black hole has been present since the beginning of the universe and is likely not moving. This massive entity is quickly consuming everything in its nearby area. The discovery was made by Dr. Lucas Fu and Professor Alastair Z of the Ben Gurion University in Israel. According to their findings, the supermassive black hole is nearly 8 billion times heavier than the Sun, making it an enormous object. Fortunately, it is found at a great distance from Earth, around 129 billion light-years away. Still, it is moving closer as the black hole consumes everything in its vicinity at a rapid rate, as shown by the redshift. When the JWST began sending back its mysterious data, analysts were thrilled as they sifted through the information. 3 small objects with a faint red glint caught their attention, and they initially believed it was a nearby large black hole. However, upon further analysis using gravitational lensing, they discovered something far more intriguing. The discovery of similar phenomena in other early universe supermassive black holes has provided new insights into the movement of both the black hole and its host galaxy, as well as the connection between the two. This remains largely unknown, but it may be proof of the early-stage evolution of massive objects, such as star-forming materials that fell into black holes. Space scientists cannot yet see exactly what is happening in the images returned to Earth, but one thing is clear. The James Webb Space Telescope is constantly finding new, bizarre objects every day. We have the joy of exploring space and being captivated by the stunning lights of planets and stars that float across the universe, light years away. Not only does the JWST allow us to see far beyond what our eyes can appreciate, but it has also uncovered a mysterious object in one of its pictures. This picture, which focused on something else, was taken by the European Space Agency while observing 2 young stars forming about 1.47 light-years from Earth. However, there is a tiny mysterious object, a small orange mark at the bottom of the picture, that seems to resemble a question mark.
Obviously, this little picture is far from insignificant. In fact, it's gigantic. The question mark shape was captured while observing the plans of young stars, known as Herbig-Haro objects, which are surrounded by enormous rings of gas and dust. As for the question mark shape itself, it may be that, due to the 2-dimensional picture presented by the Webb, it appears this way from its particular viewpoint. Right now, we have no idea what it is, and without further study, we might never know. Nonetheless, the discovery has been confirmed by experts, and it's possible that this could be a distant structure or perhaps galaxies interacting with one another. The disturbed question mark shape could be an aftereffect of their coordinated endeavors. Given the flood of distant exaggerated structures uncovered by the JWST, there is an ongoing surge of new unpredictable requests. Everyone's eyes are focusing on a particular set of Earth-sized planets that could hold the key to finding extraterrestrial life. The long-standing difficulty, which includes the absence of evidence for advanced extraterrestrial life in the universe, notwithstanding the high probability that such entities exist, could finally be settled. Where are these planets? They sit exactly 40 light-years from Earth, in a nearby star system known as TRAPPIST-1, which has 7 planets orbiting it. In their quest to find habitable planets, NASA is considering a broad variety of standards. Beyond the planet's size and distance from its star, a more sensible approach is to assess the general conditions of the planet's atmosphere, as this would allow researchers to determine if the planet is habitable. The Infrared Spitzer Space Telescope, which is part of NASA's space exploration mission, uncovered the 7 harsh exoplanets orbiting the same star, TRAPPIST, some time ago. The James Webb Space Telescope has now measured the temperature of TRAPPIST-1b, one of those planets. The JWST has consistently made pivotal discoveries since its launch, and this finding is only the latest in a series of record-breaking firsts. This is the first discovery of light produced by an exoplanet as small and cool as those in our own solar system. No other telescopes have had the capacity to measure such weak mid-infrared light. Space scientists were excited when they first learned about the 7 TRAPPIST-1 exoplanets, as these distant worlds are all Earth-sized and dwell in the habitable zone, the area where planets can have liquid water on their surfaces. However, the TRAPPIST-1 planets are beyond our current reach, found a staggering 235 trillion miles away. They orbit a star much smaller and redder than our Sun, known as an M-dwarf star. These stars are far more common in the Milky Way than Sun-like stars and are ideal targets for planet trackers. However, M-dwarfs are also more prone to erupting and sending high-energy radiation, which could harm emerging extraterrestrial life or a planet's atmosphere. When we turn our attention to TRAPPIST-1b, we find that it is tidally locked to its star. One side of the planet is constantly facing the star, while the other remains in perpetual darkness. This difference in temperature creates extreme conditions, with the daytime side reaching temperatures hot enough to melt iron, while the dark side stays much cooler but still warm enough to prevent the development of methane, a key atmospheric gas. Although this may reduce the planet's true potential for hosting life, the JWST's ability to measure these extreme conditions offers a unique view of distant exoplanets and their atmospheres. The discoveries made by the James Webb Space Telescope, JWST, have been nothing short of groundbreaking. The JWST's ability to capture infrared light allows scientists to peer deeper into the universe than ever before. This is crucial because many of the most intriguing phenomena, such as the earliest galaxies or distant exoplanets, emit radiation that can only be observed in infrared wavelengths. Unlike visible light, infrared light can pass through cosmic dust and gas, offering clearer views of objects that were previously obscured. This capability enables the JWST to uncover the most distant galaxies and objects that may hold clues to the universe's origins. The vastness of the universe has always been a source of both wonder and mystery. Every discovery made by the JWST adds another piece to the puzzle of how the universe operates. One of the most exciting aspects of the JWST's observations is the potential to uncover signs of life beyond Earth. Whether it's the detection of water vapor on exoplanets or the identification of potential atmospheric conditions conducive to life, the JWST is steadily shifting our understanding of what constitutes a habitable environment. Scientists are now able to study distant planets in greater detail, assessing whether their atmospheres contain the necessary ingredients for life, such as water, methane, and oxygen. The search for habitable exoplanets has become a central focus of the JWST's mission. Its ability to measure the composition of exoplanet atmospheres provides scientists with invaluable data on whether these planets are capable of supporting life. The TRAPPIST-1 system, in particular, has become a prime target for study. With 7 Earth-sized planets orbiting a star only 40 light-years away, TRAPPIST-1 is one of the most exciting prospects in the search for life. Scientists are especially interested in the planets in the habitable zone, where conditions might be right for liquid water to exist on their surfaces. The James Webb Space Telescope is also playing a crucial role in expanding our understanding of supermassive black holes. These enigmatic objects, which reside at the centers of most galaxies, have long been a subject of fascination for astronomers. The JWST's observations of black holes that formed shortly after the Big Bang are providing critical insights into how these massive objects evolve over time. The discovery of an exceptionally large black hole from the early universe was a key achievement for the JWST. This black hole, which is thought to be nearly 8 billion times the mass of the Sun, could provide vital information about how supermassive black holes formed and grew during the universe's infancy. In addition to its contributions to understanding distant galaxies and black holes, the JWST is also making strides in the study of star formation. By observing regions where new stars are born, the telescope is helping scientists better understand the processes that govern star birth. Herbig-Haro objects, which are regions of intense star formation surrounded by gas and dust, are some of the most exciting targets for the JWST. These objects provide a window into the early stages of star formation, giving scientists a deeper understanding of how stars like our Sun come into existence. The scope of the James Webb Space Telescope's impact on our understanding of the cosmos is immense. With its advanced technology, the JWST is revolutionizing space exploration by uncovering previously invisible objects, observing galaxies at different stages of development, and revealing the potential for life in distant corners of the universe. Each new discovery offers fresh insights into the fundamental workings of the universe, from the birth of stars to the formation of galaxies and the behavior of exotic objects like black holes. As we continue to study the data from the JWST, it becomes clearer that this telescope will shape the future of astronomy for decades to come.
The capabilities of the JWST also represent a new era of collaboration among scientists worldwide. The data gathered by the telescope is being shared with research teams around the globe, fostering international cooperation in the pursuit of understanding the universe. These collaborative efforts ensure that the discoveries made by the JWST will have a lasting impact on multiple scientific fields, from astrophysics and cosmology to the study of planetary science and the search for extraterrestrial life. As the JWST continues to explore the universe, its contributions will help to refine our understanding of the cosmos and our place within it.